Take a look at how Tesla wants to introduce humanoid robots into the workplace. Eventually, these machines may find their way into homes like yours. So, come along with us as we explore Elon Musk revealed humanoid robot. Now let's take a ride. Elon Musk is revealing a prototype of his highly anticipated humanoid robot, Optimus, and ABC's Deirdre Bolton has more. The robot was literally unveiled for the first time by Musk and the Tesla team at Tesla's 2022 AI Day. As you are aware from the previous year, the Optimus robot was simply a person dressed up in a robot suit. Because of this, they would want to create some expectations regarding the Optimus robot. They've come a long way, and when measured against that, the result is going to be amazing. This is the very first time that the team has tried using this robot without any kind of backup, assistance, cranes with mechanical mechanisms, or cables. It is the first time the robot has functioned without a tether, so this is the same as the basic, self-driving computer that runs in your Tesla vehicles. They wanted to show a little bit more of what they've done over the past several months, with the robot just going around and dancing on stage. Now, they'll show you some movies of the robot doing several other things. You will be able to observe the neural networks that control the autopilot operating, as they have just been retrained for the Bud ride on that new platform. When you see a rendered view of what the robot sees, you can see that it can very clearly identify objects like this, which means that a watering can is the object that it should pick up. To connect the data to train your networks, which they then use to deploy on the robot after picking it up, they use the same procedure as they did while developing the autopilot. This is an illustration that focuses more on the upper body, such as the shoulders and the arms. What you saw was a robot that was referred to as Bumblebee. It is a sort of primitive development robot that uses semi-off-the-shelf actuators. However, they have progressed further than that already. The team did an outstanding job and as a result, now has an Optimus bot that is completely created by Tesla, including its actuators, battery pack, and control system. At first, it wasn't quite ready to walk, but a few weeks later, it started walking on its own. To demonstrate all of the capabilities of the robot, which is something that is fairly near to what will be put into production, they wanted to show out the robot. Therefore, let's get it out there, and let's do it with the degrees of freedom that we anticipate having in the Optimus production unit. One of these degrees of freedom is the capacity to move all of the fingers independently from one another. It has opposable thumbs in both left and right hands, thus it can handle tools and do other useful tasks because it has 2 degrees of flexibility in its thumb. Our objective is to construct a functional humanoid robot as rapidly as time permits. The Optimus Prime is planned to be an incredibly powerful robot that can be produced in very high volume, possibly even millions of units, and it is anticipated that its price will be significantly lower than that of a vehicle. The total amount may be less than $20,000, yet the potential for optimism is only recognized by a small percentage of people. Demonstrations of Tesla's hot software integration are on the way. Hardware updates over the months that have passed since then, but in the meantime, they have also been working here on the design of the next generation. Even though a great deal of progress has been made since the previous year, there are, nonetheless, some aspects that have not altered at all. You'll note that we continue to maintain this extremely comprehensive true-to-life concentration on the human form. On this screen, the actuators are displayed in orange and our electrical system is displayed in blue. The actuators will be discussed in a moment. Because of this, their battery pack is located in the middle of a torso, which is technically the torso. It has a capacity of 2.3 kilowatt-hours, which is sufficient for performing the duties of an average workday. Going on to sort of the brain, it's not in the head, but it's pretty near also in the torso, which is pretty unique about this battery pack, is that it has all of the battery electronics integrated into a single PCB within the pack. This is what makes it special. Because they have our central computer, we are still going to perform everything that a human brain does, including processing data relating to vision, making split-second judgments based on various sensory inputs, and communicating. Therefore, it has wireless connectivity, audio support, and hardware-level security features that are necessary to safeguard both the robot and the humans around it to support communications. They'll need to add some limbs to this guy now that have a sort of core, and they'd also like to briefly demonstrate the actuators and completely functional hands. Now when it comes to the layout of the powertrain, a car and a robot share quite a few features in common. energy, mass, and cost are the three most essential factors to consider in this scenario. In this particular instance, you observe a vehicle that is equipped with two drive units. These drive units are put to work to bring the vehicle's speed from 0 to 60 miles per hour or to navigate a city. Even though the robot has 28 actuators, it is not quite clear what their functions are. As a result, they have higher-level jobs such as walking, climbing stairs, or carrying a heavy load that needs to be translated into joint specifications. To be more specific, the rotary actuator incorporates a mechanical clutch that includes an angular contact ball bearing on both the high-speed side and the low-speed side of the device. There is a cross-roller bearing, a strain wave gear in the gear train, 3 integrated sensors, and a custom permanent magnet machine. Therefore, a half-tone 9-foot concert grand piano can be raised using the actuator. They can perform broad aperture power grasps with their fingers thanks to their metallic tendons, which are both flexible and robust. Our fingers are also designed for the precise holding of small, thin, and fragile objects. Some fundamental information regarding our hand includes the fact that it possesses 6 actuators and 11 degrees of flexibility. It has a controller that may be held in the hand that operates the fingers and receives sensor feedback that is reported directly from the autopilot to the bot's current state. It is the exact occupancy network that we will be discussing later in a little bit more detail with the autopilot team that is currently operating on the bot in this video. Since they had to retrieve the training data again, the only thing that had changed was that they were also investigating ways to improve those occupancy networks and would be utilizing the development of radiance fields to provide a stunning volumetric portrayal of the surroundings of the bots. More neural networks have been trained to recognize high-frequency features and important locations in the camera feeds of the bot and to track them over time and across frames as the bot moves about its environment. These points help us determine the position and trajectory of the bot as it moves about its environment. As an illustration, some machinery that the bot could need to work with. Additionally, the motion control code can be seen being used in the product simulator in the video down below. The simulator shows how the tasks performed by the robot have evolved. As you can see, they started extremely slowly in April, but as they've unlocked more joints and dug deeper, their progress has accelerated substantially. To manipulate objects as naturally as possible and as quickly as practical, they have been working on more complex approaches like arm balance during the past few months. They started by creating a collection of examples of natural motion, or demos, as the first phase. The second step was to modify these online motion references to reflect the current context. So, for example, if they have a human demonstrating how to pick something up, they can acquire a motion capture of that demonstration, which can be seen right here as a series of keyframes. The placements of the hands, the elbows, and the torso are represented by these symbols. They can map that onto the robot by utilizing inverse kinematics, and if they collect a number of these right now, they will have a library that we can work with. But a single demonstration cannot be generalized to the variance that exists in the actual world. For instance, this would only work for a box at a specific area. What they've also done is put these reference trajectories through a trajectory optimization tool that solves where the hand should be. This allows us to determine the optimal position for the hand. How should the robot maintain its stability when it needs to adjust its motion to react to the real world? For example, if the box is at this location, then our optimizer will create this route instead. During the coming weeks, the first action that needs to be taken is to gather optimists who are at least on par with Bumble C, the other bug prototype you saw earlier, and possibly beyond. To make this product a reality and transform the entire economy, they are concentrating on the actual use case at one of their facilities. The quickest time frame was between 6 and 8 months, however, it all took place in a matter of months. What is your thought about these humanoid machines? Leave a comment down below. Thanks for watching, see you in the next video.